Alright everyone, in today's lesson we're going to talk about section C, scalar multiplications. Okay, so in this case we're going to draw a two line. Okay, we're going to draw two lines. These two lines is parallel each other. So in this case, this line is A. Okay, we have another line. So basically, the line we can represent as 2A because the multiplication is the magnitude is 2 times of A, or we can also write as A plus A. Okay, so if this is the case, okay, so let's write for instance. Basically, they are all in the same direction, right? Let's say this is all in the same direction. Okay, so when the vector A is multiplied by a constant K, then the operation is called scalar multiplication. Okay, let's see the concept. How the concept rests. So when a vector A is multiplied by a constant K, so then this operation is called as what? Calls as a scalar multiplication. Okay, so basically this is the operation we call it. We give a name of this. Okay, and second concept is what? The second concept is, okay, so the product K times A is called we also give a name. So what is the name? The name is scalar multiple of A and also defined as below. So what is below? First one. Okay, so when this K is more than 0, it's greater than 0. So what we get? So the K A is a vector with a vector with a magnitude K times this. Okay, the magnitude of this vector, and they have the same direction, and the same direction as A. Okay, we're going to draw this like this. A. Okay. Second one. So for the K less than 0. Okay, so what we get? So K times A is a vector with what? Is a vector with magnitude minus K times magnitude of A. and what? In the opposite direction. Plus A. Okay? Then the last one. 3. Okay, so when k equal to 0. Okay, let's say k is equal to 0. Let's say k is equal to 0. So okay, so if this is the case, so k times A is 0 vector. So they have a magnitude as 0. Yeah, it's a magnitude as 0. So this is how we find out, right? So, okay, that's also another important concept. It's a very important concept here. Okay, so for any vector A or KA, if they are parallel, in this case the K cannot be 0. Okay, so that's another one. So for any vector A and K times A are parallel, if these two vectors are parallel, if these two vectors parallel, then the K cannot be 0, right? So this is very clear, right? They are either it's the same direction or opposite direction. Okay, for this one. So, but in this case, if they are two of them parallel, then K cannot be 0. Okay. So, and we also can get the other one. The other way is that if K is not equal to 0, then A and K times A, if K can be more than 0 or less than 0, they are all parallel to each other. Okay, so this is very important concept here. Okay, let's continue. Okay, so we also can find out some general rules for this multiplication of those vectors. Okay. Okay, there's also some general rules. Okay, so if let's say this one, some following rules. Okay, if U and V are vectors. Okay, if these two are vectors. Okay, and M and N are real number, a real number. So we have two. Okay. So one we have U, V, and then M and N. So U and V is the vector. M and N is the real number. So then we will have very important rules. The first one is what? The first one is M plus N times U equals to what? We can bring them in. Okay, M U plus N times U. Okay, because they are the real number, right? And the second one, so what we get? So M is the number plus U plus V. So we also can bring them in, become M U plus M V. Okay, so that is what we get. Okay, so this is very important to rules related to the vectors multiplications, right? Okay, this is very important. So they are all numbers, right? So two. So we can differentiate this one from here. We can draw this way. We can just make sure this is the vector, this is the vector, 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 and vector. Okay, so this is the vector. Okay, so M and N is the real numbers. Okay, and also, so if let's say we express, if let's say we write one of the vector, maybe we see we write in the column vector, in the form of column vectors. So we can also find the scalar multiplications of their components. So we also can do in this the same way. So if how to express in this way. So in the scalar multiplication of the components, x component or y component. So we can get this. Okay, so if let's say we have k times view, we also can write k times x and y. So x component and y component, if this is the case, so we can bring them in. Okay, we can bring them in. Let's say k is and k is a scalar, so it's a number. For example, it's a number, it's not vector. Okay, so if this is the case, we can bring this in. We can bring this in. Bring this in. So where k is a scalar, so it cannot be a vector. Okay, this must be a number, a real number, or anything. So probably I can just express. Yeah, so this is the vector. This is the only vector. Okay, so this is very clear, right? So this is the very important two items. Okay, so we can say that. Okay, but always remember these two different items. Okay, one. Okay, so how we can do the multiplication? We can just bring them in. We have this, and if this is the number, so these two vectors we can just bring in. M times u times v, right? So if let's say they write in the x and y component as a column vector, so and k the scalar, so we just do this multiplications too, times the x component and y component respectively. Okay, now let's look at one example. Okay, let's look at one example. So, for example, for instance, we have an example. So, if let's say we write here, so we have this example. So, given b equals to what? 3, 6, right? And q equals to minus 2, 5. And then r equals to m. Let me write m here. M and 4. Okay, so if this is the case, so we find A is what? A is find the 3p plus 2q. So what's B? B is find the 4p minus q. C is what? C is the find vector p and q are prepared. So let's find. So if vector p and r are parallel. So let's find first one. First one is to find the m. What's the second one? Second one is find value. Find, what is that? Find the magnitude of P and the magnitude of R. Okay, so this is the question, right? Let's draw a line here. Okay, we're going to resolve this question here. Okay, so what's the solution? Solution. Okay, so first one, A. A is what? A is 3P plus 2Q. So in this case, we just bring them in. Okay, 3. What's the P? P is 3 minus 6. Then plus 2 times Q minus 5. So how we get the answer? So this one, we just bring in the 3. Okay, bring in 3 is 9. Here is how much? 18, right? Then plus minus 4, 10. So what we get? What do we get? We just getting, because now become the vectors plus another vectors, right? So in this case, so what's the answer? The answer is 9 minus 4. Then 9 plus minus 4 becomes 5, right? And the other one we just add them together. Minus 18 plus 10. So we get minus 8, right? So this is the answer. So the first one answer is what? 5, 8. That is the answer, right? Okay, let's look at the second one. So B. B is a 4P minus Q. So what is that? What we get? We just bring the P. P is 3 minus 6 plus minus Q. Q is minus 2, 5. Equals to what? Let's look at here. So in this case, we bring the 4 in, right? So it becomes 12. And this one is minus 4, 24, right? 4 times 6 is 24. 24 minus 24, then minus. So this one is nothing changed, right? So from here, so what's the result? So 12 minus minus 4, minus 2. So what we get? This minus cancel each other, so we get 14, 1, 4, right? So the next one is minus 24, minus 5. So what we get? Minus 29. Okay, so we get answer. The answer is what? 14 minus 29. Okay, so that's the answer. Okay, let's look at the next one. C. C is what? So if this P and Q is parallel, P is parallel to R. So if this is the case, what we get? So if let's say two of them are parallel each other, so there must be a K, a constant K in between. And then we should write in this way. P equals to K times R. Right? So R is the constant number. So also take note, R cannot be K, because recall what we discussed in the just now. So we can see that K cannot be equal to 0, right? So this is what we learned just now. Okay, let's find out the K. So let's find out M first. Okay, so if this is the case, so we can write here P. What's the P? P is 3 minus 6 equals to K times R. Where's the R? M 4, right? So since, okay, then we also can bring in from K times M also is K times 4, right? So since these two columns are equal each other, so if this is the case, then if two column vectors are equal each other, then their x component and y component also must be equal to each other. So if this is the case, 3 equals to K times M. Minus 6 equals to K times 4. So what we get? So from here we can get what? We can from this is the 1, this is 2. From here we can get what? K. The K equals to what? K equals to, we have to, if I know K, we have to bring the 4 here, right? So it's minus 6, 4. So what we get? Cancel the 2 each other, become minus 2, 3, right? So this is the K. We found the K. Now, since we found the K, let's bring the K. 3 equals to minus 2, 3 times M. So what is the M? So M, because 3 and 3 we can cancel out each other, right? Then we just bring both sides times minus 2. Both sides times minus 2. Then we can cancel each other. So is this the case? We will say is minus 2, right? Now we get an answer. So what's the answer? The answer is m equals to minus 2, right? Okay, so from here we know the minus 2. Okay, now let's look at the second one. It's 3. Okay, so second one we're going to probably we can draw here. Let's do the second one here. Okay, so this is the first one. This is the one. Let's do the second one here. 2. Okay. So P. So what's the P? P is 3 squared plus minus 6 squared. So what we get? We can get answer is this is 9 plus okay, this is the P. So we get R. R equals to what? R is to minus 2, right? Minus 2 squared plus 4 squared, right? So from here we know this is the 4 plus here 16. So we get what? 20, right? So 20 is magnitude. So if this is the case, so how we find this? P minus R. So what we get? 45, 20. Okay. So because this is the thing, we can just bring them in, right? So what we can, how can we cancel off? So we just cancel off each other. So this is how we get this for 45. So this is this is 5 plus 9. So here is 5 plus 4, right? We cancel the 5 each other, so we will get answer. The answer is 2, 3, right? Okay. So this is what we get. Okay. So if this is the case, we can get an answer. The answer is what? The answer is 2, 3. 3 over 2, right? So this is the answer. Okay, that's all. This is for the exam 14. Okay, thank you for watching. We'll see you soon in the next video. Thank you. Bye.